And he discussed this engine and various other things with Small on his progresses around the place. But his existing contacts in Glasgow University and the local engineers, together with his contacts around the country, so he carried on really discussing these and not much else on that side. William Small was very significant. He was a Scottish medic with wide-ranging interests who'd settled in Birmingham, and he advised Watt on the patent, and it was his advice not to submit that drawing. One of the problems in getting under the skin of significant people in our history is that very often we only have their portraits towards the end of their lives, when they're established with their fellowships and honours. We don't really know what they looked like when they were making their great contribution. We've just seen William Small, who died quite soon after success in getting the engine operating in Birmingham. So that's reasonably okay. But what about James Watt? Now, this is a portrait that I'd known for many, many years. It appeared in Keith Gale's book for the Birmingham Science Museum in the 1950s. It was stated to be by William Beechey, but it's obviously much earlier than the famous portrait, which is reasonably well known to those who delve into Watt's history. It could well be a conjectural portrait showing Watt younger than the famous portrait. I'm very grateful Joanne Curtis actually tracked down the painting of which this is an image, which came into the Birmingham collections in 1910 and is dated considerably earlier than the Beechey portraits. So maybe we've got some idea of what Mr. Watt looked like when he made his great advance. Matthew Boulton is much easier to deal with. We have two portraits of him from about this time, when his business interests were already wide. But he was very interested in Watt's improved steam engine, both to solve his immediate power problem and for a manufacturing market which he was interested in entering. He was born in 1728 to a father who was establishing himself in Birmingham metal trades, particular toy trade, small metal goods, often of fairly high value. He joined the business and in due course inherited the business from his father when his father retired. The business was in central Birmingham, but Boulton wanted to expand. In about 1760, he began developing this factory at Handsworth Heath, about 2 miles out of town. Soho Manufactory, the first substantial factory really in the Birmingham area, was water-powered. You remember that there were upwards of 60 watermill sites within 6 miles of the town centre, but they were all relatively low-powered, as was the water provision here. Boulton began to find his activities seriously limited by lack of power, particularly in the summer months. He needed more reliable power, possibly by steam. He considered various means of back pumping the water wheel in his factory with a savoury type, very crude sort of steam pump. Maybe a Newcomen engine, wasn't happy about that. Maybe Watt's engine would solve the problem much more efficiently. Now, James Watt met Boulton, and he found that here was this man in Birmingham with many interests, but also central to a group of men of different professions with many different interests, the Lunar Society. This was a similar group to the one based in Glasgow University that had given him intellectual stimulus to develop his ideas, and who found the support of their network invaluable. There was much discussion of the steam engine with people in the Lunar Society and how to exploit Watt's great advance. Boulton, though, made it clear that he would only come into the business of making steam engines if he could market them to the world, and not just the 3 counties which Roebuck at that point was suggesting. So let's just look a little bit into the Lunar Society and some of their people. It included a number of GPs. William Small, we've already met. Another GP was Erasmus Darwin, seen here, based in Lichfield. Now, he was constantly delving into mechanical problems. But he travelled thousands of miles each year to visit his patients, and he had several nasty accidents in his horse-drawn wagonette. He decided that these were caused by steering geometry, the centre pivot front axle, which was used in all coaches and wagons. And you can see the problem here. Instability when turning a tight corner, possibly to avoid the really deep potholes which the roads had in those days. The front axle is moving perilously close to the centre of gravity. Darwin started working towards a system which became adopted later, of course, on motor vehicles, which we call the Ackermann system, where the front wheels are pivoted from the ends of the front axle, which doesn't turn, and hence the vehicle is much more stable. This may well have been one of the people that Boulton talked to Watt about, saying what a wonderful range of people there were in the Lunar Society who had all these bright ideas and did their best to investigate them. Darwin's other activities included a vertical shaft windmill. He thought it would be an improvement on the traditional windmill. This wasn't adopted very much in the early days, but many of those small wind generators that factories and things are starting to have a vertical shaft windmill to power them, sitting up on the roof, slowly turning. This sort of thing showed great flexibility of mind. Great for the sort of informal discussions that the Lunar Society so much enjoyed. And it's possible, but by a bit of jiggling with the dates for the journeys to and from London, Watt may have attended one or more of the Lunar Society meetings while passing through Birmingham. If anybody's interested in Darwin's activities in Lichfield, his house is now a museum and well worth visiting. There's one of the leaflets for the house here, if anybody wants to have a look at it. It's free admission, and I've cribbed several of the illustrations for this from that museum. Another notable name in the Midlands was Josiah Wedgwood, whom Watt had known from his interest in the Delftfield pottery in Glasgow. Wedgwood, in fact, always referred to Watt as his fellow potter, although he was also very interested in steam engines and installed steam engines at the plant in Stoke. Stoke was a bit too far for Wedgwood to be really a member of the Lunar Society, but the Lunar Society, because it had no constitution, seems to have had an awful lot of corresponding members and those who kept in touch and those who sent them documentation of their achievements. So they really were a clearinghouse for a lot of detail. You may have seen a TV programme, relatively recent. There's been a very nice one on the television with a piece of Wedgwood pottery being manufactured with fluting on it, rather like this fluting on the bottom here, being achieved on an ornamental lathe. It's one of these lathes where the workpiece moves sideways, controlled by a lobed cam, a whole series of different cams with different numbers of lobes for the circuit. Very nicely done on that particular programme. And Boulton is thought to have either inspired Wedgwood to get one of these lathes or even have arranged the supply of an early form of ornamental turning lathe. The one that was actually shown on the television programme would be much later, but nonetheless very identifiable. James Kier had attended university in Scotland and then went off to join the army. eventually came out and embarked on careers in chemistry and glassmaking, including involvement in industry in the Stourbridge area. He was later to become the manager of the Soho manufactory as Boulton became more and more involved in the steam engine business. But Kier also managed the Watt document copying machine process. Machines like this, which were effectively the first commercial document copying process, sold quite well for a number of years. And indeed, the process was still in various forms being recommended over the next 2 centuries because it was so difficult for any sort of forgery to take place. But that's another story, so we'll leave that to another time. An artist based in Derby who was also interested in many subjects, similar to the Lunar Society, was Joseph Wright. He sought to understand what light was, how it behaved, as well as becoming a painter of landscapes and portraits and so on. He wasn't a member of the Lunar Society, but he had, like many others, he regularly corresponded with them, and his ideas and so on were discussed at length. He produced graphic paintings like this one of Vesuvius in Italy. And members of the Lunar Society were very interested in all sorts of aspects of geology, both as natural phenomenon and as a source of useful materials for exploitation. Some of Watt's paintings really are quite delightful. He depicted a lot of scientific demonstrations, like this one with an orrery demonstrating the movements of the planets. In this one, the source of light, which looks a bit powerful compared with what he'd have actually had in an 18th century orrery, the source of light is where the sun would have been, in the middle of that representation of the solar system. But in some of his other paintings, he gets away with putting the light source in a most unnatural position because it lights up the enthusiasm and interest of the people looking at it. And he just gets away with it because it makes a jolly good story. Maybe of more interest to the Lunar Society was this very nice illustration of the face of the moon by John Russell, a friend of Joseph Priestley. And this was done in 1795 from very careful observation of the moon. Again, he wasn't a member of the society, but he regularly corresponded with them. So he was, if you like, part of the larger Lunar Society, with their contacts and correspondence. One of Wright's portraits is of John Whitehurst, who was a clockmaker based in Derby. He later developed the counter to be used on beam engines to count the number of strokes when the fee system that Boulton and Watt used required an accurate and secure way of counting the movements of the beam, the number of strokes. He was particularly interested in geology and also developed an innovative pyrometer, as Wedgwood had, to measure high temperatures very accurately, crucial to all sorts of processes. Whitehurst produced, from his geological studies, particularly a strata of rocks and faults occurring within those strata, with illustrations such as this from his book, Inquiry into the Formations of the Earth, in 1778. Advances in geology which helped miners for coal, metal ores and other minerals to understand just what was going on and where the seams that they were looking at went to when they struck a fault. Had they gone up or down? And studying these could show whether they'd gone up and been eroded and vanished, or had they gone down, in which case they might be too deep to get to, but it might be worth having a bit of a burrow. All sorts of things like that, again, rotated round this idea of flexibility. The Lunar Society would have impressed Watt and given him the feeling that he could receive an intellectual stimulus similar to that he received from his friend in Scotland. But all looked well as he returned to Scotland to try to resolve the problem of obtaining an accurate cylinder for the full-size engine when the machining of cylinders was simply not accurate enough. They were all too wobbly. The casting wasn't terribly good either. You get inclusions and all that sort of thing in it. But he also continued his other business activities. But he was away from home on canal and other projects quite a lot of his time, and his wife ran the business in Glasgow. But then work on the steam engine was slow. He even tried to make a smooth, accurate cylinder by rolling a sheet of tin and soldering it up. But he couldn't make it a perfect cylinder, and it still wasn't adequate. And then, a couple of years later, Watt's life was turned upside down. First of all, the banks and investment market in Scotland failed, and work stopped on the canal projects, so his income from all those dried up. Then Boulton's finances became ever more critical as investment in the engine dried up. Watt's finances weren't sufficient to carry on financing it. And then finally, his beloved wife died suddenly while he was away on business. He returned to his 2 children and became pretty depressed. The Boulton and Small were aware of the situation and seemed to have handled it pretty diplomatically. Boulton, to start with, swapped Roebuck's debt for stuff he'd had from Boulton for Roebuck's share in the steam engine. So Boulton acquired that interest in the steam engine. Watt was offered a salary and a home for him to complete the development work in Birmingham. And once the engine business was established, he would have a partnership in it. And so he packed all his tools and his experimental engine, left his children with relatives in Glasgow, and set out for Birmingham, where he arrived in May 1774. Now, one of the things that Boulton and Watt were a little concerned about was by this time 5 years of the patent protection had already been used up. So they set out to use earlier precedents, particularly the Newcomen Savary Act of Parliament, which extended Newcomen's patent, or Newcomen's engine, to operate under Savary's patent, a very general one. And so they were able to extend Watt's patent through to 1800. The other problem, steam cylinder, was moved on by one of Boulton's Midland contacts. John Wilkinson was an innovative ironmaster who had set out to make cannon with a really accurate bore. And he developed a boring machine considerably better than anything that anybody else had achieved, including Smeaton, who was involved a little bit on this. The range and accuracy of cannonballs was much improved if the ball simply went straight up the barrel instead of rattling around because of its imperfections. One can see why Watt could be attracted to a location with contacts like these and other members and associates who created such a network of knowledge and experience and a willingness to share their findings. Wilkinson had developed a cannon boring machine. The cannon itself, along here, was rotated in bearings in a substantial frame, and a robust boring bar, sitting here, fed in from a robust stand, was able to cut the bore with very, very little deviation. It worked, and it brought business to Wilkinson's foundry. But he was also on the lookout for any other products. He was consulted about the engine cylinder and the need for greater accuracy. Fortunately, Watt's experimental engine had an 18-inch bore, so with its flanges and pipe stubs, it could be rotated in the same sort of space as a large cannon in the larger of Wilkinson's cannon boring machines. It worked. By the time the Patent Extension Act had been passed by Parliament, the experimental engine was returning the performance in power and efficiency that Boulton and Watt hoped for. Full-size engine orders were taken immediately. A 38-inch engine for Wilkinson himself, and a 50-inch engine, that's the bore of the cylinder. So we're up from 18 inches to 50 inches for Bloomfield Colliery over into the Black Country. And all this lot started despite Watt wanting to proceed rather slowly and steadily, while Mr. Boulton wanted action, not constant fiddling, as he might have put it. There were certain occasions on which one feels there was a little bit of friction between Messrs. Boulton and Watt in how to proceed on these things. Meanwhile, the innovative Mr. Wilkinson had already redesigned one section of his cannon boring machine to make large cylinders, to deal with the machining of large cylinders. They were too big to be rotated, so the cylinder itself was bolted down. The difference between steam cylinders, particularly the way in which this was being developed, and cannon was that the steam cylinders were open both ends. Many Newcomen engines would only open one end, but it was easy enough to alter them. So they were open both ends, whereas the cannon, of course, wasn't. So a substantial slotted tube went through the middle. A couple of really robust bearings being rotated by the water wheel, and with a rod pushing a cutter, close-fitting cutter, along this tube to give an accurate bore. The result was a cylinder double or treble the size, and even larger than the experimental engine cylinder, could be produced at very similar accuracy. Early on, Boulton reported with pride that the cylinder only deviated from a perfect by the thickness of a worn shilling. Diabolical by our ideas of accuracy these days, but nonetheless, at that time, it was a significant improvement. You know, rather better than being able to get a finger in the gap. And so the Watt steam engine rode forward into history. Now, the Watt engine, which I've worked on for 40 years or so, and researched for a similar period, was built and put to work in May 1779. And what itself quite innovatory. Watt had tried excessive, expansive working. That's closing the steam valve as the piston was descending and letting it coast on the pressure behind it and its own inertia to complete the stroke as a means of modulating the engine, power output and so on. Unfortunately, the engine was virtually unmanageable. Became known as Beelzebub, the devil. Now he wanted to try to modulate the engine's performance to further reduce the waste of steam and to allow its performance to be matched to the particular load being put on it. So he introduced a mild form of expansive working. And this engine, now in the museum 2 floors down, is the machine on which this was tried out. He equipped it with a third valve, operated from the beam, in order to allow that cut-off. And he immediately got an 18% saving in fuel compared to previous engines. And he wrote off around his assistants who were building engines around the country, Boulton Watt engines, telling them what to do to make the improvement. If you could get 1/100th of that improvement in efficiency, you could get a lot of money from people still using steam engines, whether it's in nuclear submarines or nuclear power stations or whatever. It was, at that time, it didn't seem that much of a step forward, but by our standards it was enormous. This photograph shows the engine being dismantled for preservation in 1897. It then passed through a preservation site at Ocker Hill to the old Science Museum and now to this museum. It is the world's oldest working steam engine, older than any Newcomen engine. At least it will be a working engine when we manage to repack the water pump in a 21st century building constructed to 21st century building regulations, because unfortunately we can't clamp onto the frame of the building. So we now have to build an enormous gantry, and funding for that's taken a little while. But we'll get there. In particular, we'll get there by next year, of course, the bicentenary of James Watt's death. Do remember that we're talking about a 30-inch diameter cylinder and piston. So, Boulton and Watt went on to supply 450 engines by the time the patent expired. And many were of later designs to power factories, as well as offering increased power and efficiency. And at this age, Boulton could look back on a life of real achievement, and with a reputation, in no small measure, helped by his partner, James Watt. Both men were elected Fellows of the Royal Society and given many other accolades. And as at various other places, and particularly next year for Watt and a few years ago in 2009 for Matthew Boulton, they will be mentioned in all sorts of places. And I feel they may be up there looking down as we celebrate their contribution. But I have to admit, I think Mr. Watt, a very dour man, might have huffed a little at any of this sort of attention. Thank you.
Right, as usual, we have the opportunity for questions. We've got plenty of time. At least half an hour, I think, if we need it. There are two roving microphones, and I would appreciate it if you could get hold of one of those before you actually start asking a question or adding supplementary comments or anything like that. The other thing I should just mention is that, as usual, we're hoping to get a video recording of this lecture, which may, if we get a satisfactory one, go out on YouTube. So you just, most of you will only see the backs of your heads in it, but just be aware that if you don't wish to appear too much in the video, then keep a low profile. But but it's particularly important you get the microphone, because the sound then comes through well on the video. But if you haven't got the microphone, then I can assure you nobody will hear a word you say on that, even if we can hear you a bit here. So I will do my best to spot you. The lights are not. There's one up there. Mic pops up the top there, I think. And that's better.
I'm an instrument engineer, actually. I began my apprenticeship in 1960. We still had an instrument maker. This was in a nuclear power station. This gentleman, he was near retirement, and he was in the little room at the back with his machinery, lathes, milling machine, etc. And he repaired mechanical instruments for us. And the other thing is, John Whitehurst, the Nottingham Industrial Museum is the Basford beam engine. It has a Whitehurst counter on it. And my daughter's a library assistant in the Nottingham Subscription Library, and they have a Whitehurst clock, and that has a number of villages, and written on it is how much in advance or behind the Greenwich Mean Time they are. About 3 or 4 of them. Most amazing clock. Thank you.
Thank you.
And certainly the variation in time across the country, never mind anything to do with calendars and so on, really used to catch a lot of people out. It suggested that the unified time was really introduced when people kept missing their trains, as trains ran to a timetable, and life hadn't really run to timetables before.
I believe Christchurch in Oxford still keeps Oxford time, and so they have to adjust it when Choral Lever Song is broadcast, because it has to go on Greenwich Mean Time for one Sunday a year or something, but the rest of the time it's 4 minutes past or something like that, or 4 minutes too. So I don't believe we've...
Yeah, somebody over here.
Yes.
Thank you. The Newcomen engine was obviously single acting. Was, just to clarify the point, is the Watt engine double acting, steam being applied to both sides of the cylinder alternately? The other point is you haven't mentioned very much about the patents aggravations that Watt was so much involved with. Could you say anything about that?
Sorry, about the patent?
Patents, yes, patents.
Yeah, sorry, what aspect of it?
Well, I believe he was very much involved in taking up his rights. He thought people were infringing his patents.
Yes. Right. The early Watt engines were all single acting. There were beam engines using chains, so the pull was in one direction only. Once they wanted to push, then we're into considerably later in the period I've been talking about today, when Watt, there had been earlier attempts at double acting, but none of them terribly successful. Watt developed the parallel motion to allow the piston to push the beam up while maintaining reasonably straight line motion. And then from there on to initially the sun and planet gear to allow rotative action, although that became a problem as powers went up because it couldn't transmit an awful lot of power. But it got round any problems over a crank pattern that somebody else had. And the governor was developed, and so on. As far as the patent actions later, eventually the patent was vindicated, but it wasn't until 1797 that the legal actions resulted in the law coming down on Watt's side in terms of the patent being justified. A number of designs were produced which tried to get round, but if they were using condensing, then it was the condensing engine aspect which caught them all. And eventually, the majority, where they were condensing, gave in and negotiated terms to pay up their back royalties. The high-pressure engine, of course, wasn't affected. And so by that time, there were high-pressure engines being developed, Travathic and so on, and those weren't affected in that aspect, so long as they didn't condense.
Thank you. I think he gained a lot of money from his patents, but he was too mean to pay for somebody else's crank bearing arrangement rather than the planet wheel.
No, the advantage the fact that somebody had a patent on the crank, which had been around for donkey's years, could have been challenged. Watt didn't particularly want to challenge it because his patent was equally a little bit dubious. But the other point is that he was interested in engines which were going to drive machinery, and particularly textile mills. And the important point there was smoothing out the irregularity of the engines. And the Sun and Planet gear, whilst it was still a reasonable power level, the Sun and Planet gear was much more successful because it doubled the speed of the flywheel immediately, and therefore it quadrupled the smoothing effect of the flywheel. And in fact, those rotative engines don't really have a flywheel. They've got a very large drive gear, but they haven't got the mass that a flywheel would have had because they didn't need it, because they were running so much faster.
Thank you.
Yes.
I'd just like to make a comment from my own experience of visiting Soho House. The picture you showed of the moon, when I first saw, I don't know whether it's the original or a copy of it, on the staircase in Soho House, I thought it was a photograph of the moon.
Yes.
And I had to look and read the caption to realise that it was actually a painting from the 18th century.
Yes.
It's photorealistic.
Yeah, very realistic.
Thank
Yes. Good.
Yep.
When you think about it, the steam engine is quite a remarkable device. It had a master pattern for the first third of the 18th century and another master pattern for the last third. Has anything else ever happened, been like that? Thank you.
Did the other great industrial cities like Newcastle on Tyne and Manchester have anything like the Lunar Society amongst their intellectuals?
There were philosophical societies. They tended to be a bit later. They tended to be at a time when these great polymaths, with the likes of Lunar Society, were tending to be more specialised, I think. And so they didn't have quite the wide-ranging discussions and maybe quite the wide range of interests and abilities that the Lunar Society and that group in Glasgow. They may have existed within universities, but those societies involving industrialists and so on were rather less linked to the universities.
Another question, are there any descendants of Watt and
Yes.
the rest of the...
Descendants of both families. Gibson Watt, one of Watt's line descends through the daughter, and the family she married into, Gibson's, adopted the Gibson Watt name by deed poll. Boulton, similarly, there are descendants. I'm not sure of the detail.
Thank you.
We got David Hulse.
And another one there.
Yes, another
Take
one.
David first, and then
Yes.
then the gentleman in the green.
Jim, I've got a reference to John Southern as the designer of the counter. Was it Whitehead or John Southern or both?
I think the situation is Southern is the one who's likely to have said, we want something that will do X, and may well have gone out of his way to find something and then arranged how they were going to make it so that the customer, bless their cotton socks, couldn't fiddle it. Whereas Whitehurst was the one with the pedometer mechanism. And so, as much as anything, I think it was a collaboration.
Yes.
But without Whitehurst's involvement in the clockwork finesse, I don't know that it would have been as successful.
So it could be a joint effort between the two.
Effectively, yes.
Yes. Thank you.
Phil? Phil, there's one just behind you. Just. Yeah.
So, thanks for the talk. Very interesting. I know that a lot of Boulton Watts machinery was sent down to Cornwall, and it's a long way to Cornwall. How did they get it there? Before the railway?
For the railway.
And motorway.
A glorious mixture of canals and road and sea. You would send it by whatever means you could to the nearest coast and then take them round the coast. And then from there, by the shortest route to where the customer was. There are some interesting accounts of trials and tribulations once the canal system was developed down to the south, of debate about what was the biggest size cylinder that they could manage to transport through the tunnels and bridge holes. The bridge holes maybe were less of a problem than the tunnels, but either way, the canals were a tight restriction. So there were a lot of problems. You might not start from here if you would go into making ping pong balls or something.
To answer the question which Jim did of the Watt family coming down, a Hereford MP, David Gibson Watt, was in fact the MP that was there when I was living in Hereford, and he was actually living in James Watt's summer house or residence, which is in Radnorshire and was on the borders of the River Wye. So, and certainly, a lot of his papers have been distributed from various, to various places, and I believe some of them did come to Birmingham.
Oh yeah, lots of them, and a lot of equipment as well.
One of the other things was the Lunar Society. The first time I ever saw that book and bought a copy of it was in Australia, of all places. I hadn't seen it in this country, but that's where I bought my copy. And, my mind's gone a blank now. We all know this, don't we, when we... No, I'll have to come back to it. I'm sorry.
We've got...
I think I'm right in...
Yeah.
Okay. I think I'm right in saying that William Small's brass is at the back of the chancel in the cathedral. And it also records the fact that he was the tutor to Thomas Jefferson, the US president.
Right.
Yeah, certainly he was in the States in the early days.
I'm sorry, I remember now what I was going to say. Why the the Lunar Society was so successful, I have read, is because there was no side with the people who joined the society. If somebody was good, like Watt, and they recognised him, they listened to him. And this is the way things evolve, by people talking. In France, I gather at the time, if more than 4 people met, or even as many as that, the king believed there was a conspiracy and they were out to behead him.
In justification in some cases. Oh, poor old Phil came off.
The microphone bearer is getting some exercise this evening. So.
Jim, does the Lunar Society still exist in any form? Or when did it actually fold up, or what?
Well, the original Lunar Society went into abeyance in the early 19th century. Quite a few years ago now, 30 years or more ago, a new Lunar Society was formed in Birmingham. I've given them various lectures. They very often meet at Soho House. They are very different from the original Lunar Society. They are much more akin to the societies that exist all over the place with particular interests. They have a considerable interest in Boulton and Watt, but also in their other business activities and so on. So they do exist, and I have gone and given them lectures. Yeah.
Thank you. One behind you.
I've actually been to, I have one of kids, I remember the think tank, and I've been in this room to a Lunar Society meeting of a couple of them a few years ago, before you started coming here. Yeah. In the Lunar Society, coming. Thank you much. Yep.
Thank you very much.
We happen to be the first lecturer who exists here.
Any others?
Try Mr. Constable. Front sheet.
Yes, down in the front.
You'll probably get the hiccups in the middle of this, which I apologise for.
What with coughs and hiccups?
Well, exactly. I've been hiccuping all the way through. So, early on, Jim, you talked about the calendar change. Personally, I've never really understood A, the background, and B, the effect of that. Can you just give us a little bit more information about the calendar?
You're liable to get a lot more, because it really, I spent some time writing it out a little bit more carefully, because it really is one of those things that is sometimes a bit difficult to get your head around. You think about it, a calendar is a means of keeping our lives and records in really to fit in with the seasons and that sort of thing. So when we give a date, it actually means something. And if we're giving a date on one system and the person we're talking to is on another system, it's just as bad as if they misheard the month you said. In ancient times, they fairly soon established that the year was around about 365 days, maybe a little bit, year on year. But quite early on, they began to realise that there was a bit of a creep taking place. And so the Christian churches in 325 AD adopted what's called the Julian calendar. And this was where you turned the real year, which is around about 365 and a quarter days, into 365 days every normal year, and every 4 years you have a leap year. And that worked well enough. But the other thing that had existed for a long time and continued to exist was that New Year's Day was the 25th of March, for religious reasons. In fact, the year is a little bit less than they thought, by about a third of a day each century. And so in the 16th century, a new calendar, the Gregorian calendar, was suggested, because by that time there were 10 days adrift. With that calendar, only had a leap year in the centuries, which were divisible by 4, but only in the centuries where the first 2 digits were divisible by 4. So they got rid of 3 out of 4 leap years every 4 centuries. No, sorry, they got rid of 1 every 4 centuries. That corrected it. And the continental and the Catholic Europe adopted it over the next few years in the 16th century. England and the Protestant states weren't going to have anything to do with this. It was the Roman Catholics. Oh, no way. And so they stuck to the old ways. But by the time they got into the 18th century, it really was getting a little bit ridiculous. They were now 11 days adrift. And of course, they were adrift from the continent by 11 days. There's a lovely incident which the Postal Service sometimes is rather faster than people think. And there was a researcher, quite a few years ago now, it's been written up, but anonymously, of course, who put all the letters between somewhere presumably quite close to the coast of France and people close to the coast of England, where transport could be fast enough. And he put them into strict date order, failing to realise that they were 11 days apart, and made some rather curious deductions about where the ideas were coming from. So, by the middle of the 18th century, England decided to do something about it, and they passed an Act of Parliament in 1752 which would sort out two things. First of all, they knocked out the 3rd to the 13th of September that year in order to get us back on track. This resulted in riots from people who thought their lives were being shortened by 11 days. They also moved New Year's Day to the 1st of January, which was why Newcomen Society, failing to realise this, celebrated in the wrong year for Newcomen's birth, and why I was concerned for Watt's birth. For a long time, the dates in this country were identified as being old calendar or new calendar, and so people who were in the know knew what was going on. Other states slowly followed, and now, almost across the entire world, except for the island of Fula in the Outer Hebrides, which still works a different system, we all work the same system. And it's now close enough that all they need to do is put in the occasional leap second at the end of occasional years. And the other Protestant states carried on for a long time and then joined the club. But the Russian and the Orthodox Church countries were very late. And in Russia actually only changed in 1923. This is why sometimes the revolution that brought the communists in is talked of as the October Revolution, and other times as the November Revolution, depending on which calendar you're looking at. The one little silly outcome of all of this is that the 29th of February in the year 2000 is actually the most delayed date for the final enactment of any provision under an Act of Parliament, because that was then a leap year in order to correct all the other things that had gone on. And the other thing that we've still got, and we celebrate it every year, is that in 1752, the Exchequer said, oh no, you can't mess the year about like that. We have got to continue to have a proper year for our accounting. And so they moved the date of New Year in the Exchequer's year by those 11 days. And so the financial year still ends on April the 5th, the tax year. And that's still the situation. So every April the 5th, when you talk about your tax return and things like that, you are celebrating another aspect of the change in the calendar system. I think it's fabulous. But it does make people realise and maybe think a little bit about what we actually mean by these things. It's obviously having an effect on people.
Are there any more questions? Wave your hands now, or I think
we're done.
I think we're done. Yes. So, I think apart from being enlightened about the history of the calendar changes and so on, I suppose at least with Brexit we can go back to the Julian calendar. I suppose if we want to. So. No, it's been most interesting, both the stories about the actual inventions of the engine and the developments thereof, and the other members of the Lunar Society. So I think we've learnt quite a lot. So let's give Jim the usual expression of thanks.
Good. Thank you.
Just need to wait a few seconds for Jim Ranahan to